Okay, we're back and we're looking at circuits. In particular, we're looking at resistor circuits where we need to find the single most important thing that people like engineers would be interested in are currents. How many amps, how much current is flowing through each particular resistor. So we're looking at these in terms of series and parallel sets, combinations of resistors. And basically, like we do in class, we're really just using the same steps over and over again to try and work this thing out. Basically, we're looking at finding total resistance, which allows you to find total current. Especially if you have multiple sets of parallel resistors, you want to redraw this circuit as a series circuit. The benefit of doing that, the reason we do that, is in series we can find voltages. We can find the voltage differences, which allows us to go back to the original circuit and then find what the actual currents are and how they split when they go into parallel sets. So basically, there's two main things we have to remember here. In series, resistors have the same current. Okay, there's only one pathway in series. Whatever your current is has to go through everything on that path. In parallel, your current split. However, each branch has the same voltage. That's what parallel basically means. So it's probably best just to go right to an example. So here's a bunch of resistors connected to a 30-volt battery, a couple sets of parallels. So we want to find the total current, we want to find out how the current splits in those two parallel sets. So the first thing we need to do is figure out what the total resistance is. We can do that because we know the rules. You can add them in series, and then in parallel, you have to do the reciprocals. So for example, on the right-hand side, we'll have 1 over 4 and 1 over 12, which should give us 3 ohms of resistance. In this other part here, we have a total of 6 ohms on the bottom branch, and so we have 6 ohms in parallel with 3 ohms. Add those reciprocals together, flip it over, and we should get 2 ohms total. Okay, so the fact that we have multiple parallels means we could probably redraw this thing. Let's just make it easier on ourselves. Okay, I'm going to do that like right up here. So we have our 30-volt battery. We have the 10 ohms on top. We have a total of 3 ohms on the right, and we found a total of 2 ohms on the bottom. So in series, they just add together, so we can find our total resistance is simply 15 ohms. Our total current from Ohm's law is 30 volts divided by that 15 ohms, which is 2 amps. So the fact that we've redrawn this in series means that we have 2 amps flowing through everything. Okay, there's only one pathway. That 2 amps has to flow through every component, the battery itself, etc. That allows us to figure out voltages. And from Ohm's law, voltage is current times resistance. So if we have 2 amps going through 10 ohms, let me change colors here, that means we have 2 times 10 is 20 volts up there. On the right we have 2 amps going through 3 ohms, so the voltage difference across that resistor would be a total of 6 volts. And then down on the bottom, if we have 2 amps going through 2 ohms, that gives us a voltage difference across that resistor of 4 volts. Remember Kirchhoff's rules. Check yourself as you go through this. 4 and the 6 and the 20 add up to 30 volts total of the battery. Chances are we're right. That's looking good. Okay. Now remember, the reason for doing this is to get those voltages for the two parallel sets. then we can go back to the original picture. So for instance, on the right hand side we have 6 volts. What that means is that each of these branches sees the 6 volts. Okay, now if you imagine the current coming down, you have 2 amps coming in to this junction point, and we know it's going to split and go down those 2 branches. Now we can figure out exactly how it goes down those 2 branches. We're looking for currents. Well, according to Ohm's law, current is voltage over resistance. So on the left branch, 6 volts divided by 4 ohms is 1.5 amps. On the right, 6 volts divided by 12 ohms is half an amp. Are we right? Yeah. Those two add up to the 2 amps, following Kirchhoff's rule. That's looking good. Now at that junction, we get the 2 amps back. It goes, and now it splits again in that parallel set. Well, according to our picture, we have 4 volts across there. So that means we have 4 volts on the top branch, and we have a total of 4 volts on the bottom branch. It's actually easier to think of this instead of 2 resistors. Just go ahead and think of that as, as a 6 ohm resistor. Okay. Now let's see what we get. On top we've got 4 volts divided by 3, so that's probably easier to keep that as a fraction. 4/3 amps on the top branch. And now on the bottom we've got 4 volts divided by 6 ohms. Are we correct? Well, 4/3 amps is the same as 8/6 amps. 8/6 plus 4/6 gives you 12/6, which is 2 amps. That adds up to the total. Looking pretty good. That must mean that we're correct. So we've nailed down what the total current is, how it splits in each of these. Notice on the bottom set, in reality you have 2 resistors on that bottom branch with 4/6 amps. Well, that's going through each of those because they're in series. They have to have the same current. So we now have everything about this particular circuit. About the only other thing that they could ask for, maybe something in terms of power. Okay, where power equals current times voltage, which is the same as I squared R, etc. But we have all the numbers. You can pick and choose whichever version is easiest for you, and we can actually find how many watts of heat are being generated in these resistors, what the total power is being delivered by the battery, things like that. But more importantly, we figured out the currents. We used just a few little steps here, just a couple rules. We've got Ohm's law, and V equals IR. We've got the 2 Kirchhoff's rules. Voltages add up in series, currents add up in parallel, and we know how to find series and parallel resistances. With those small numbers of rules, we can figure out pretty much all of these different types of circuits with resistors. I hope this helps, and until next time, we'll see you later.